Welcome back, students. This is the session 1 from the playlist of Electromagnetic Induction. This is an introductory session in which I will be discussing about the induction of an electric current in the closed coil due to the changing magnetic fields. So the first point here I have written is that the moving charges produce magnetic field. This is the first point which all of you must be knowing about it. That is, and the current which is flowing in a conductor is found to generate or produce magnetic field around it, and this can easily be seen by placing a magnetic compass near the this current carrying conductor. When you place a magnetic compass, the needle of the magnetic when you place a magnetic compass near the current carrying conductor, then the needle of the magnetic compass will get deflected. So which proves that the current which is flowing in a conductor produces a magnetic field. Similarly, Henry and Faraday, they found that the changing magnetic field induces an electric current in the closed coil, and this is one of the experiments which they did in order to come to this conclusion. So what they did is that they connected one closed coil to this galvanometer, and they brought one bar magnet near this coil and started moving this bar magnet through the closed coil. So when they pushed this bar magnet through this closed coil, they found a deflection in the pointer of the galvanometer, and they also found that this deflection was seen till the time there was a relative motion between this bar magnet and the coil. That is, this deflection or this pointer of the galvanometer was showing deflection only when this bar magnet was in motion, and when this bar magnet stopped or was held stationary, then in that case the pointer was not showing any deflection. They also, what the Faraday and Henry, they also, what they did that they pushed this bar magnet through this coil, and they noted the deflection, and again what they did, they started moving this bar magnet away from the coil. So when they moved the bar magnet away from the coil, they found the deflection, or you can say the pointer in the galvanometer was found to get deflected in the opposite direction. So with the help of this experiment, they found that the electric current was induced in a closed coil due to the changing magnetic field, and the direction of the current also got reversed when the bar magnet was pushed through the coil and when it was moved away from the coil. So this was a very simple experiment which they conducted in order, and they, with the help of this experiment, they came to a conclusion that the changing magnetic field induces an electric current in the closed coil. So in the next session, I will be discussing about the magnetic flux and the Faraday's law of induction. So till then, have a nice day. Bye.